Hello, this is Miss Van Horn doing the test corrections video for, we'll call it Unit 4, but it was our second unit. This is our Trig test. So whenever you're doing Trig questions, you always want to make sure you have your formula sheet, okay? So I'll be using these. These are the two key ones. They're going to use tangent and cotangent all the time. Then we've got these reciprocal identities over here. And then the Pythagorean identities. This one I'll start, but we also probably, when you get your sheet on your midterm or your final, I would go ahead and write 1 minus sine squared theta equals cosine squared theta. And then over here, secant squared theta would equal 1 plus tangent squared theta. And then over here, cosecant squared theta would equal 1 plus cotangent squared theta. So we might see these later. So you want to have your formula sheet ready as you're taking the test. So we're going to start with number 1. And to do this video, I'm actually going to use the TI calculator. It's the same steps, kind of, sort of, as Desmos. These are for the folks that are going to use TI, especially next year as your next step ready, going to college. So we have this table here, and when we see pi, we know that we are in radians, okay? So no matter if you're in Desmos or if you're using the TI, you're going to put it in radian mode. So on the TI, here's the mode button. And as you can see, it starts out in radian mode. If it was degrees, I'm going to have to switch over later in the test. So I'm going to get out of that screen. And then just like in Desmos, we have to set our window. So this is our scale, because we're going by pi over 2. And our x max is 3 pi over 2. And here's our range where we're looking for our y values. So if I push window, because this is where we're going to look, my x max is at 3 pi over 2. Now I could say pi, I could say 2 pi if I wanted to see it. So on Desmos we normally push 2 pi, but on the calculator here there actually is a pi symbol. So second, this little caret key, that's going to give me 2 pi as my x max. My x min, we're going to say is 0. We could say it is 1, and my scale, again I'm getting right here, would be pi over 2. And then just like in Desmos, we're not going to go below 0 here, but we could say, you know, for example, we could say -5, and then we could put this up to 5. If we don't see anything, we could change our scale, and we're going to go by 1s. So to put your function in the TI, you're going to push y equals, and then I'm just going to put in the equations and see which one matches the values. So in my first one we have 0.5. It's been a while since I've seen the cosine button, but here it is on the TI. We've got cosine right there. So 0.5 cosine of 2x minus pi, and then I'm going to close that parenthesis. And I got two. Yeah, there we go. So now I push graph. And don't know if you can tell, but you can see the function here, and it's graphed. Now on the TI, I can pull up the table and see what I see, or I can trace. So if I pull up the table, notice I don't see any pi's. Desmos is a little bit nicer, okay? So my y value, now if I push, so 0 is -0.5, and then if I try to convert here, you know, let me see if I trace. Do they give me, oh, they don't give me pi over 2. Desmos is, y'all are going to get spoiled with that Desmos, but here is pi over 2, and we can see it's at 0.5. And then if I go to my next value, we see, so it's at -0.5, and this is -0.5. I kind of skipped over 3 pi over 4 because it is right at 0. So you can see the Desmos gives you an advantage because it's going to give you the exact points. Whereas in this one, I actually have to do my math, 4.712. What I might have wanted to done with the TI calculator, if I get out of here and I see pi over 2, so pi divided by 2, I'm looking for 1.57. So I might want to label that. And then 3 pi over 4, I might want to label that 2.35. And then pi we know is 3.14. And then 3 pi over 2, 3 pi over 2, we know is that 4.712. So if I go to my table, right, now I'm looking better. I can do second calc, and now I can say, oh, a value, what about when x is, I wonder if I can just put pi over 2. Oh, there we go. What about, so I'm calculating, so second calc, I'm putting in a value. What about when x is 3 pi over 4? And now, you get kind of confused with this one because it's e to the negative 4. That means it's really close to 0. And then pi, second calc, a value, if I put in pi, I get the negative 0.5. And basically, this one, the first one matched. And if you put this in a Desmos, so the only difference would be in Desmos, your x value is going to be greater than or equal to 0 and less than or equal to 2 pi, and your scale will be pi over 2. And then your y, if you do it in the standard window, you could say 10, negative 10, scale of 1. And in Desmos, it's really easy to see once you put it on there because you can hover over those points. Okay, number 2. How does the graph differ? Okay, so we're comparing this graph to this one, okay? And they give us an interval, x values that we're going to look at. So we could graph these and see how it changes, or we can just look at the parent function. So we know right away this amplitude is a half, that amplitude, because nothing there, is 1, so my amplitude is smaller. So when I look at that, I go, okay, C and D are out. And then it's talking about the period, so remember, period is 2 pi over b, which is this number in front of x, right? So on this one right here, 2 pi over 2 would be pi. And this one over here, there's nothing in front, so it's 2 pi over 1. So the period in this case is smaller, which means it's shorter. So that answer was A for that one. Okay, number 3. So we're just matching an equation. So when you go to put it in Desmos, your x value is going to be less than or equal to 3 pi, greater than or equal to, and we can use negative pi. And the scale that they use, because this is what we see, these are our tick lines, is pi. And then my y is greater than or equal to, it looks like negative 1, and less than or equal to, it's up to 5, but I'd actually kind of go to 6. And a scale is 1. So when you type, when you put this in a Desmos and you find the graph, now on the TI, okay, I'm going to go to Window, and instead of this x is less than or equal to, my max I'm going to say is 3 pi, and my scale is pi, and my y max I'm going to say is 6, and my y min is negative 1. And now when I graph, look, I actually didn't take my old graph out, so I have to wait for it. Alright, so I'm going to go through the functions, and I'm going to see which one matches. So, let's see, y equals sine of 3x plus 4. Oops, let me put it in right. I took out my sine. It's been a while since I've used this TI, so 3x. It wants me to close that, so it actually wouldn't take it until I did that. And then we have cosine of 2x plus 2, and then 2 sine x plus 3, I'm going to do these three and see if I get something that matches. So this is A, and it is not the same midline, so that's not it. There it's graphing B. Not quite it because it dips down, but there we go. This third one, which is C's answer, is an exact match. So if I turn off the other ones, and this is how you turn off your graphs in the TI. Oh, oops. I just wanted to tell that not to graph it. So I'm going to hover over this equals. That means I turn it off. I'm hovering over that. I turn it off. So now if I just graph that one by itself, you can see that that is the match. That's the graph that matches that. And that answer was C. Alright, number 4. We have an acute triangle, we have an angle, and we have two sides. So when I think, what can I use, right? Do I have any matching pairs? I do. And we want to know x degrees. So seeing how I have a matching pair, I can use the law of sines. And basically, I want to find an angle, so I'm going to say the sine of m over 23 equals the sine of L, which is 48 over 25. Now before I put this in the calculator, I'm switching from radians to degrees because these are degree modes right here. So when I find my answer to this, I have to remember that I want m, and I have sine here, so I have to say sine to the negative 1 of sine 48 times 25, and then that is going to be multiplied by 23. So when I put this in my calculator, first thing in Desmos or the TI graphing calculator, you're going to want to go to mode on the TI, and we are going to put this in degree mode. That allows me to get the correct answer. So when I go out of here, on the TI, notice the blue button up here. If I push that, that will bring up sine to the negative 1. So there it is. It's in there. Let me see if you can. The TI is a little bright. And then I'm going to push sine of 48 divided by. Now the Desmos looks a little bit nicer. And I don't think you have to put in as many parentheses. So let me see, delete. It's being a little fussy about my use of parentheses here, so I need to put this in parentheses. And now I can times it by 23. And 43.13. And so the closest answer is C. And that was the answer. So it's not B, it is C, because it was 43.13. Okay? Alright, so flipping to the next page. So when we get to these, you got two methods you can use, guys. Two methods. One method, use your formulas. Okay, work these little formulas. If you love puzzles, you probably love working these formulas. If you don't love puzzles, you probably just want to like pick 20 degrees and plug it in for everything and find the matches. But since we are practicing, and this is test corrections, let us go ahead and solve it the way they really intend us to solve it. So secant is, if we look it up over here, secant is 1 over cosine of theta. So this one right here is 1 over cosine of theta. And then if we multiply by sine theta over, now see how this is cosine? We don't really want to use tangent. Tangent can be written as something else. It can be written as sine theta over cosine theta. But we got this big old thing. We need to simplify this. So this is really sine of theta times cosine of theta over sine of theta. And so what happens is these sines cancel. So this whole thing right here is really cosine. So it's 1 over cosine theta times cosine theta over 1. And then these will cancel. And then you're thinking, oh my god, no answer matches. They kind of try to play a trick on you, because if you have this sheet right here, remember how I told you to write something down real quick? one of these is equal to 1. Cosecant minus cotangent is equal to 1. So then you had to look up your answers and see which one matched. So the other way to do this, I could have, and I think Desmos is much easier to do this with, to be honest with you, because see where it says secant? When you look on the TI calculator functions here, you got sine, you got cosine, you got tangent. And I don't think, I could be wrong about this. I don't see that. Let me see if there's any, if I push math, let me see if I get cosecant. Nope. So if you're using the TI, you really don't want to use the cheat way, because you're not going to be able to type in secant 20 times sine 20 over tangent 20. You're going to have to do it the old way. So just know that. Alright, number 6. This guy, whew, I was like, what did I do here? So when you do this without the cheat way, okay, now this way technically we've got cosine, we've got sine, we've got tangent, right? So if I were to do it, I call it the cheat way. If I were to do it in my calculator, right, because I didn't want to do it the long way, I could say cosine of 20 divided by 1 minus sine of 20. Did I close that? I'm going to close that because that's the whole thing. Minus the tangent of 20. And that gives me 1.064. Blah, blah, blah. And then, oh man, again. Okay, so I have to know that secant, when I go to type this in the TI, I don't have a secant, right? Secant is, on my formula sheet, where is it? Secant is 1 over cosine. So I would have to say 1 divided by cosine of 20. Now Desmos does this for you. So in this case, Desmos is better. Ah, and I got lucky, because right off the bat, the cheat way, I get secant, I get this match. Now, if I do it the long way, which is really what we should be practicing, we want to make these denominators the same, okay? So that means originally, I'm going to, because these are cosines and sines, I'm going to write this cosine of theta over 1 minus sine of theta minus sine theta over cosine theta. And the reason I did that is I kind of want all of the same. That's a sine. I don't know what that looks like. So I want all of these to be the same. Okay? Now, what I'm going to do to get these denominators the same, I'm going to multiply this side by cosine theta. And I'm going to multiply this side by 1 minus sine theta. Okay? And then when I do that, up here I'm going to get cosine squared theta over cosine theta times 1 minus sine theta minus, okay, sine theta minus sine squared theta over cosine theta of 1 minus sine theta. So when I do this, okay, want to cross out anything that's in common. It looks like when I thought on my paper, I said, ouch, this one hurts. I'm going to do it the cheat way. But you don't need to do that all the time. Let's think here. This here can be rewritten as sine theta 1 minus sine theta. So when I do that, I've got that on the top, and then I also have, so when I rewrite it, I got cosine squared theta minus sine theta. I think it would be, actually, I'm just going to leave that, minus sine theta plus sine squared theta all over cosine theta 1 minus sine theta. Okay. cosine squared theta plus sine theta, that is 1. And so I end up having, up here is 1 minus sine squared theta, and so that means all of these cancel. So I end up with 1 over cosine theta, which is secant theta. That was a lot of work. So you decide which way is better, which method is better for you. Alright, number 7. Again, whew, this one was a beast. If you plug this into your TI, if you plug it into Desmos, just use 20, and you could type secant, you can type cotangent, and you could type tangent, okay? But if you do not have Desmos and you have a TI calculator, you're not going to be able to type in secant or cotangent. So let's do it the longer way. So let's look at this bottom piece right here, okay? We're going to look at the bottom piece. So the way they're written, we can't really add it. So we're going to rewrite this cosine theta over sine theta plus sine theta over cosine theta. And we can't add them like that. We have to have the same denominator. So I'm going to multiply this side by cosine theta and this side by sine theta. And I end up with cosine squared theta plus sine squared theta all over sine theta cosine theta. Now if we remember this part right here, that's really equal to 1, okay? So when we write this, we've got secant theta divide, and then we're going to say times, and then we're going to flip this. So when we flip it, we got sine theta cosine theta all over 1. Okay? And I think I found when I did this earlier, I was like, is this really helpful? Well, secant can be rewritten as what? Secant can be rewritten as 1 over cosine theta times, now we got sine theta cosine theta over 1. Well, this cosine and that cosine would cancel, and you would just end up with sine theta. Now what I noticed when I was doing this, which is the right answer, B is the right answer, I noticed I did it a different way, so just want to show you the different way I did it. I rewrote, and I'm not sure why, I rewrote cotangent 1 over tangent, which that is true, minus tangent, and I multiplied by tangent, and I ended up getting 1 plus tangent squared, and I said that was secant squared over tangent squared, and then I multiplied, and I ended up getting the right answer. So what you love about these, you can do these more than one way. That's just the way I decided to do number 7. Obviously, you can put 20, 20, 20, type it into Desmos, and find the match. Number 8. Looks kind of not friendly if we're just trying to reduce it. What you're going to want to do here is, I would start with the denominator. Some people start with the top. So if I start with the top, let me do something different right here. If I'm looking at this, right, and bring it down here, I have sine theta over cosine theta plus cotangent is cosine theta over sine theta. And so what we're going to do, again, we're going to multiply this side by sine, this side by cosine, and I end up with sine squared theta plus cosine squared theta all over sine theta cosine theta. That's the top. I'm going to multiply it by something. What am I going to multiply it by? Well, let's see. Secant, so if I take this side, okay, secant is 1 over cosine theta times sine theta. And that ends up just being sine over cosine. So when I multiply, I'm going to say cosine theta over sine theta. So this right here is 1, right? So we end up with cosine theta all over sine squared theta cosine theta. The cosine thetas cancel, and end up with 1 over sine squared theta. And then you're like, yay, I got it. Oh man, it's not there. But we have to remember that cosecant squared theta, this guy is equal to 1 over sine squared theta. Because cosecant on my formula sheet cosecant is 1 over sine, so cosecant squared would be 1 over sine squared. Okay? So that was a long way. Again, you could type it in Desmos, put a 20 where the x's are, and find the match. You'd be typing a while because D is your answer. Alright, number 9, I kind of like doing these by hand. The box method, so we get cosecant x plus 1 times cosecant x minus 1. So we get cosecant squared of x plus cosecant x minus cosecant x minus 1. So in the box, when you do your box method here, these two are going to cancel, and you get cosecant squared of x minus 1. And you're like, man, which one is that? Well, if you look over here, cosecant, where's this? Cosecant squared minus 1, if I pull this 1 over here, and if I move this cotangent to the other side, I would get cotangent squared, and so the answer is D. And again, you could type 20 in and then find the match. Number 10, same thing, secant of x plus 1, secant of x minus 1, so you get secant squared of x plus secant x minus secant x minus 1, so these cancel, and I get secant squared of x minus 1, so secant squared of x minus 1, if I brought this 1 over, then I would move this tangent over, and then I would get tangent squared theta, C. Alright, not too many left to go. Alright, number 11. Alright, cool. I don't have any denominators, so let me look at this. This is 1 over cosine of x, right? So that means whoop, shoop. That cancels, right? But I still end up with, if these, so secant, did I make sure I did that right now? Make sure I did it. Secant of x is 1 over cosine theta. Yep. So I end up with 1 minus cosine squared of x. And what did we say 1 minus cosine squared of x was? 1 minus sine squared of x. And I got that off my formula sheet. Number 12. Okay, so I'm going to change this up. Cotangent is really cosine squared of x over sine squared of x. And then if I multiply that by sine squared of x, those cancel. So I have cosine squared of x plus cosine squared of x. When I add, I'm just adding the coefficient, so I get 2 cosine squared of x. And also you could put 20 in where the x's are and then find your match in Desmos. 13, home stretch. Let's see what we got here. I'm just going to rewrite some of these. Okay, so cosine squared, I'm going to leave that alone. That's a whole one. And then cosecant squared, well, I can say that this is 1 over sine squared of x, or theta, I should use theta. Cotangent could be written as cosine squared of theta over sine squared of theta. And then sine squared of theta, that's just going to be over 1. So in order to get all the same denominators, I'm going to need to multiply these two by sine squared theta. So I end up with sine squared theta cosine squared theta over sine squared theta plus 1 over sine squared theta minus cosine squared theta over sine squared theta, and then plus sine to the 4th theta over sine squared theta. Okay, so how to simplify this? When I look here, and I'm adding, right, they'd all end up over sine squared theta. And now when I'm adding these, I get 1 minus cosine squared theta. What is that? 1 minus cosine squared theta. 1 minus cosine squared theta is sine squared theta. Okay, so I have that. Now I can factor each of these terms has sine squared theta. So I say sine squared theta. And then what's left here is cosine squared theta. If I take sine squared theta out, I'm going to have plus 1 plus sine squared theta. These cancel. And now let's see what I got. Cosine squared theta plus sine squared theta. These two pieces right here, cosine squared theta plus that, they are equal to 1. So 1 plus 1 is 2. Or you could put 20 in for your thetas, 20 in these, and find the one that matches. So you could do it either way. 14, which has the greater amplitude. Remember, amplitude is positive always, so this amplitude is 2, and this amplitude is 4. And so which one is greater? G of x, right? And that's definitely the method I would use for that one. And then I'll go over this bonus. We have an angle, which is this right here, and we have two sides. And this angle does not match that other side. So suppose that each foot of land along the street, the annual tax is $25 per foot. The diagram shows the plot of land. About how much is the annual tax for the plot? So, and it's the street tax. So the only side we care about, and we're going to multiply about, is this one, okay? So if I label this A and that little a, we don't have a matching pair, so I'm going to have to use the law of cosines. Okay, and so a squared would equal b squared plus c squared minus 2bc times the cosine of a. Okay, so, and then when you finish this, right, square root, now when I get my answer, it's going to be a equals, right? The square root, what is b squared? And it really doesn't matter what b squared is. So we're going to say 28 squared plus 46 squared minus 2 times 28 times 46 times the cosine of 80. And I'm going to put that all under the parentheses. And I got this from there. I guess I labeled this one B and that one C. So that's where I got those from. And then, let me find my calculator here. I'm going to put it in here. Alright, so square root, parentheses, because I want to put this in the parentheses. Make sure you can see it. 28 squared plus 46 squared minus 2 times 28 times 46 times cosine of 80. And I get 49.525. 49.525. And then I'm going to multiply this. One thing I like about the TI is I could just push times. And I'm going to multiply that by $25. And I get $12.38 exactly. And so this is it for the multiple choice answers. I'm going to do the short answers in another video. I hope that helped you. And don't forget to turn in your test corrections.